However, once we entered the hotel, it was truly breathtaking. The lobby featured a stunning rose display, and the ceiling was beautiful. The casino was vast, but the pleasant aesthetics made the long walk to the conference area feel less daunting. As I reached the line to enter the event, my heart sank. It was so long that I feared I wouldn't get in. Fortunately, an Nvidia staff member noticed my badge and invited us to follow him. After confirming our email registration, we were escorted to the front of the line and granted access to the event. They informed us that we couldn't go to the first floor and directed us to the general admission area. On our way to the third floor, we grabbed some free snacks. As I stepped into the seating area, I accidentally stepped on a large piece of food. How embarrassing. We took our seats and eagerly awaited Jensen's entrance on stage. The show kicked off with an incredible introduction showcasing Nvidia and their innovative AI applications in various products.
Ready, go!
We have about 15 keynotes worth of material to pack in here. I'm so happy to see all of you. You got 3,000 people in this auditorium. There's 2,000 people in the courtyard watching us. There's another 1,000 people apparently in the fourth floor where there are supposed to be Nvidia show floors, all watching this keynote, and of course, millions around the world are going to be watching this. To kick off this new year? Well, every 10 to 15 years, the computer industry resets. A new platform.
They talked about the AI evolution. Jensen Huang discussed how AI has transitioned from large language models to agentic systems and physical AI.
In 2015, the first language model that I thought was really going to make a difference made a huge difference. It was called BERT. 2017, Transformers came. It wasn't until 5 years later, 2022, that ChatGPT moment happened, and it awakened the world to the possibilities of artificial intelligence. Something very important happened a year after that. The first O1 model from ChatGPT, the first reasoning model, completely revolutionary, invented this idea called test time scaling, which is a very commonsensical thing. Not only did we pre-train a model to learn, we post-train it with our reinforcement learning so that it could learn skills. And now we also have test time scaling, which is another way of saying thinking. You think in real time. Each one of these phases of artificial intelligence requires an enormous amount of compute. And the computing law continued to scale. Large language models continue to get better. Meanwhile, another breakthrough happened. And this breakthrough happened in 2024. Agentic systems started to emerge. In 2025, it started to proliferate just about everywhere. Agentic models that have the ability to reason, look up information, do research, use tools, plan futures, simulate outcomes, all of a sudden started to solve very, very important problems. One of my favorite agentic models is called Cursor, which revolutionized the way we do software programming at Nvidia. Agentic systems are going to really take off from here. Of course, there were other types of AI. We know that large language models isn't the only type of information. Wherever the universe has information, wherever the universe has structure, we could teach a large language model, a form of language model, to go understand that information, to understand its representation, and to turn that into an AI. One of the biggest, most important one is physical AI. AIs that understand the laws of nature. And then, of course, physical AIs is about AIs interacting with the world, but the world itself has information, encoded information, and that's called AI physics. AI that, in the case of physical AI, you have AI that interacts with the physical world, and you have AI physics, AI that understands the laws of physics. And then lastly, one of the most important things that happened last year, the advancement of open models. We can now know that AI is going to proliferate everywhere when open source, when open innovation, when innovation across every single company and every industry around the world is activated at the same time. Open models really took off last year.
Nvidia emphasized their leadership in the open model ecosystem, promoting the growth of AI through open source systems.
Well, it turns out we have billions of dollars of supercomputers in operation so that we could develop our open models. I am so pleased with the work that we're doing. It is starting to attract attention all over the world and all over the industries because we are doing frontier AI model work in so many different domains. The work that we did in proteins, Groot, a humanoid robotics system, Earth-2, Nemotron, Cosmos, and then today we're going to talk a little bit about Alpamayo, the work that we've been doing in self-driving cars.
Huang introduced AI agents as multi-model, multi-cloud, and hybrid cloud applications capable of reasoning, researching, utilizing tools, and simulating outcomes.
Your ability to build AI agents. This is really a groundbreaking area of development. You know, at first when ChatGPT came out, people said, you know, gosh, it produced really interesting results, but it hallucinated greatly. And the reason why it hallucinated, of course, it could memorize everything in the past, but it can't memorize everything in the future, in the current. And so it needs to be grounded in research. It has to do fundamental research before it answers a question. The ability to reason about, do I have to do research? Do I have to use tools? How do I break up a problem into steps? Each one of these steps, something that the AI model knows how to do, and together it is able to compose it into a sequence of steps to perform something it's never done before, never been trained to do. This is the wonderful capability of reasoning. We can encounter a circumstance we've never seen before and break it down into circumstances and knowledge or rules that we know how to do because we've experienced it in the past. And so the ability for AI models now to be able to reason, incredibly powerful. The reasoning capability of agents opened the doors to all of these different applications. We no longer have to train an AI model to know everything on day one, just as we don't have to know everything on day one, that we should be able to, in every circumstance, reason about how to solve that problem. Large language models has now made this fundamental leap, the ability to use reinforcement learning and chain of thought, and search and planning and all these different techniques in reinforcement learning has made it possible for us to have this basic capability, and it's also now completely open sourced. But the thing that's really terrific is another breakthrough that happened. And the first time I saw it was with Arvind's Perplexity, the search company, the AI search company, really innovative company. And the first time I realized they were using multiple models at the same time, I thought it was completely genius. Of course we would do that. Of course an AI would also call upon all of the world's great AIs to solve the problem it wants to solve at any part of the reasoning chain. And this is the reason why AIs are really multimodal, meaning they understand speech and images and text and videos and 3D graphics and proteins. It's multimodal. It's also multi-model, meaning that it should be able to use any model that best fits the task. It is multi-cloud by definition, therefore, because these AI models are sitting in all these different places, and it also is hybrid cloud. Because if you're an enterprise company or you built a robot or whatever that device is, sometimes it's at the edge, sometimes a radio cell tower, maybe sometimes it's in an enterprise, or maybe it's a place where a hospital where you need to have the data in real time right next to you. Whatever those applications are, we know now this is what an AI application looks like in the future. Or another way to think about that, because future applications are built on AIs, this is the basic framework of future applications. This basic framework, this basic structure of agentic AIs that could do the things that I'm talking about, that is multi-model, has now turbocharged AI startups of all kinds.
Nvidia unveiled its comprehensive physical AI platform, highlighting the importance of simulation and synthetic data generation for training, AIs that comprehend the laws of nature and engage with the physical world.
The next thing is physical AI. This is an area that you've seen me talk about for several years. In fact, we've been working on this for 8 years. The question is, how do you take something that is intelligent inside a computer and interacts with you with screens and speakers to something that can interact with the world, meaning it can understand the common sense of how the world works? Object permanence. If I look away and I look back, that object is still there. Causality. If I push it, it tips over. It understands friction and gravity. It understands inertia. That a heavy truck rolling down the road is going to need a little bit more time to stop. That a ball is going to keep on rolling. These ideas are common sense to even a little child, but for AI, it's completely unknown. And so we have to create a system that allows AIs to learn the common sense of the physical world, learn its laws, but also to be able to, of course, learn from data, and the data is quite scarce, and to be able to evaluate whether that AI is working, meaning it has to simulate in an environment. How does an AI know that the actions that it's performing is consistent with what it should do if it doesn't have the ability to simulate the response of the physical world back on its actions? The response of its actions is really important to simulate. Otherwise, there's no way to evaluate it. It's different every time. And so this basic system requires 3 computers. One computer, of course, the one that we know that NVIDIA built for training the AI models. Another computer that we know is to inference the models. Inferencing the model is essentially a robotics computer that runs in a car or runs in a robot or runs in a factory, runs anywhere at the edge. But there has to be another computer that's designed for simulation. And simulation is at the heart of almost everything NVIDIA does. This is where we are most comfortable. And simulation was really the foundations of almost everything that we've done with physical AI. So we have 3 computers and multiple stacks that run on these computers, these libraries, to make them useful. Omniverse is our digital twin, physically based simulation world. Cosmos, as I mentioned earlier, is our foundation model, not a foundation model for language, but a foundation model of the world. And it's also aligned with language. You could say something like, what's happening to the ball? And they'll tell you the ball's rolling down the street. And so a world foundation model, and then, of course, the robotics models. We have 2 of them. One of them is called Groot. The other one's called Alpamayo that I'm going to tell you about. Now, one of the most important things that we have to do with physical AI is to create the data to train the AI in the first place. Where does that data come from? Rather than, instead of having languages, because we created a bunch of text that are what we consider ground truth that the AI can learn from, how do we teach an AI the ground truth of physics? There are lots and lots of videos, but hardly enough to capture the diversity and the type of interactions that we need. And so this is where great minds came together and transformed what used to be compute into data. Now, using synthetic data generation that is grounded and conditioned by the laws of physics, grounded and conditioned by ground truth, we can now selectively, cleverly generate data that we can then use to train the AI. So for example, what comes into this AI, this Cosmos AI world model on the left, over here, is the output of a traffic simulator. Now this traffic simulator is hardly enough for an AI to learn from. We can take this, put it into a Cosmos foundation model, and generate surround video that is physically based and physically plausible that the AI can now learn from.
They announced the world's first thinking and reasoning autonomous vehicle AI, developed by Nvidia, trained end-to-end using human demonstrations and Cosmos-generated data.
And we've made enormous progress. Today, we're announcing Alpamayo, the world's first thinking, reasoning, autonomous vehicle AI. Alpamayo is trained end-to-end, literally from camera in to actuation out. The camera in, lots and lots of miles that are driven by itself using human demonstration. And we have lots and lots of miles that are generated by Cosmos. In addition to that, hundreds of thousands of examples are labeled very, very carefully so that we could teach the car how to drive. Alpamayo does something that's really special. Not only does it take sensor input and activates steering wheel, brakes, and acceleration, it also reasons about what action it is about to take. It tells you what action it's going to take, the reasons by which it came about that action, and then, of course, the trajectory. All of these are coupled directly and trained very specifically by a large combination of human-trained and as well as Cosmos-generated data. The result of it is just really incredible. Not only does your car drive as you would expect it to drive, and it drives so naturally because it learned directly from human demonstrators, but in every single scenario, when it comes up to the scenario, it reasons about, it tells you what it's going to do, and it reasons about what's about to do. Now, the reason why this is so important is because of the long tail of driving. It's impossible for us to simply collect every single possible scenario for everything that could ever happen in every single country, in every single circumstance that's possibly ever going to happen for all of population. However, it is very likely that every scenario, if decomposed into a whole bunch of other smaller scenarios, are quite normal for you to understand. And so these long tails will be decomposed into quite normal circumstances that the car knows how to deal with. It just needs to reason about it. And in the case of the models above that I've just shown you, The model here is called Alpamayo. And Alpamayo today is open sourced. This incredible body of work, it took several thousand people. Our AV team is several thousand people, just to put in perspective. Our partner, Ola, I think Ola's here in the audience somewhere, Mercedes, agreed to partner with us 5 years ago to go make all of this possible. We imagine that someday, 1 billion cars on the road will all be autonomous. You could either have it be a robo-taxi that you're orchestrating and renting from somebody, or you could own it and it's driving by itself. Or you could decide to drive for yourself. And so, but every single car will have autonomous vehicle capability. Every single car will be AI powered. And so the model layer in this case is Alpamayo, and the application above that is the Mercedes-Benz. Okay, and so this entire stack is our first NVIDIA first entire stack endeavor. And we've been working on it for this entire time, and I'm just so happy that the first AV car from NVIDIA is going to be on the road in Q1, and then it goes Europe in Q2, here in the United States in Q1, then Europe in Q2, and I think it's Asia in Q3 and Q4. And the powerful thing is that we're going to keep on updating it with next versions of Alpamayo and versions after that. There's no question in my mind now that this is going to be one of the largest robotics industries, and I'm so happy that we worked on it. And it taught us an enormous amount about how to help the rest of the world build robotic systems.
Huang introduced the Nvidia Vera Rubin Platform, featuring 6 new chips, including the Vera Rubin CPU, Vera Rubin GPU, ConnectX-9 Super NIC, and BlueField-4, aimed at developing the next generation of AI supercomputers. This platform also tackles the context is the new bottleneck challenge with NVIDIA Context Memory Storage Platform, aspiring to provide a unified platform for all AI.
And so today, I can tell you that Vera Rubin is in full production. You guys want to take a look at Vera Rubin? All right, come on. Play it, please.
Vera Rubin arrives just in time for the next frontier of AI. This is the story of how we built it. The architecture, a system of 6 chips, engineered to work as one, born from extreme co-design. It begins with Vera, a custom-designed CPU, double the performance of the previous generation, and the Rubin GPU. Vera and Rubin are co-designed from the start to bidirectionally and coherently share data faster and with lower latency. Then, 17,000 components come together on a Vera Rubin compute board. High-speed robots place components with micron precision before the Vera CPU and 2 Rubin GPUs complete the assembly. Capable of delivering 100 petaflops of AI, 5 times that of its predecessor. AI needs data, fast. ConnectX-9 delivers 1.6 terabits per second of scale-out bandwidth to each GPU. BlueField-4 DPU offloads storage and security, so compute stays fully focused on AI. The Vera Rubin compute tray, completely redesigned with no cables, hoses, or fans, featuring a BlueField-4 DPU, 8 ConnectX-9 NICs, 2 Vera CPUs, and 4 Rubin GPUs. The compute building block of the Vera Rubin AI supercomputer. Next, the 6th generation NVLink switch. Moving more data than the global internet, connecting 18 compute nodes, scaling up to 72 Rubin GPUs, operating as one. Then, Spectrum-X Ethernet photonics. The world's first Ethernet switch with 512 lanes and 200 gigabit capable co-packaged optics scale out thousands of racks into an AI factory. 15,000 engineer years since design began, the first Vera Rubin NVL72 rack comes online. 6 breakthrough chips, 18 compute trays, 9 NVLink switch trays, 220 trillion transistors, weighing nearly 2 tons. One giant leap to the next frontier of AI. Rubin is here.
What do you guys think? This is a Rubin pod, 1,152 GPUs in 16 racks. Each one of the racks, as you know, has 72 Rubins. Each one of the Rubins is 2 actual GPU dies connected together. I'm going to show it to you. But there are several things that, well, I'll tell you later. Now, we decided that we would create an industry standard system so that the entire ecosystem, all of our supply chain, could standardize on these components. There are some 80,000 different components that make up these MGX systems, and it's a total waste if we were to change it every single year. Every single major computer company, from Foxconn to Quanta to Wistron, the list goes on and on and on, to HP and Dell and Lenovo, everybody knows how to build these systems. And so the fact that we could squeeze Vera Rubin into this, even though the performance is so much higher, and very importantly, the power is twice as high. The power of Vera Rubin is twice as high as Grace Blackwell. And yet, and this is the miracle, the air that goes into it, the air flow is about the same. And very importantly, the water that goes into it is the same temperature, 45 degrees C. With 45 degrees C, no water chillers are necessary for data centers. We're basically cooling this supercomputer with hot water. It is so incredibly efficient. And so this is the new rack. 1.7 times.
You can't spell Nvidia without AI. They are at the forefront at advancing physical AI, training robots in virtual simulations to interact with the real world. After thorough training, this programming is seamlessly implemented, allowing robots to work alongside humans without disruption. Nvidia has created an open ecosystem that makes AI tools accessible in various formats. They also showcased the Nvidia Rubin Platform to meet the growing demand for AI and supercomputers. I found it fascinating how they developed the method to water-cool their systems using hot water. I hope this innovation makes its way into consumer products because water components tend to heat up and can harness that heat effectively. Once Jensen concluded his presentation, he invited everyone to the 4th floor to explore some of the products discussed in the keynote. We ascended and were amazed by the displays. We saw several GPUs and wished they would reveal the next generation of GPUs, but I suspected they would save that for Computex. Let's hope so. They showcased the new version of Rubin NVL72 rack, both as a wall display and through physical demonstrations.
But just, interesting ideas.
We've met many times.
As I explored, I spotted the new Mercedes CLA they featured in the keynote. A stunning car adorned with the Mercedes logos, and the headlights and taillights had the Mercedes logos in them, giving them a sleek look. Is it okay if I walk by real quick? Give me a quick second, bro. I can't wait to see them on the streets. I also came across the William Trinity Bike Project, a 3-wheeled electric vehicle reminiscent of Tron, powered by Nvidia's DGX Spark AI. With its LED wheels and exterior trim, I would love to ride one of these in my city. I heard they might retail around $30,000, but I really can't confirm that. Additionally, I saw a Tensor Robocar in person. These self-driving vehicles feature retractable steering wheels and pedals. The showroom floor had numerous robots, some designed to assist in workspaces, while others were purely for entertainment. Oh, yeah, I really want to sit down too, okay, baby, me está pegando.
You will see it on the screen.
Okay.
Capabilities design, so to speak, is quite good. But surely, I should tell us truth as well. Like, if you were putting the general together, like, how would you redesign the whole No, I haven't yet. No, I've got this side.
Franchement, tellement la LED.
Oh, it's hurting. Yeah.
So that guy was talking about anyways. I don't know if he's really actually going to have so you can do a location here on the top. If you drop down, we're going to do the Nvidia drop off. Quest. And this is just where it steps through kind of what it's doing. So there's sort of a triage of tasks that the robots can pull from, and so it'll pick it up once it gets assigned. So it's now ready for a pickup. If you want to focus, we can continue. And go ahead and hit the medium drawer. And then do make a scan. So the thing with Moxie is that it's a secure delivery. So in hospitals, they all have their own badges, and so we want to keep stuff locked, right? So we'll tap on the thing here. On the medium drawer, there is a medium drawers around back. There is a pin for you. You're welcome to grab one.
Oh, okay. Can I get two?
Just one, unfortunately.
Okay.
So that's for. So the spot. Those things are for Nvidia. So if you were to wear it, an Nvidia employee sees it, they'll give you a little something.
Oh, okay.
It's the thing that they're wanting to do.
Okay.
But yeah, so we've done our pickup. Come back around here and we'll finish the deliver. So in a scenario, we would have loaded something up in that drawer that we selected, and it's going to go to a drop off. This is for a hospital. So like for like lab medication, like labs or medications or stuff like that.
And then in between its routes, can you ask it to pick up stuff or stop somewhere?
Right, yeah, so if it's got a total of 3 drawers, so if there was another unit or something that wants to be loaded, it would be able to add on to those, yeah. And then it would in order drop off to whichever one was first. So we'll scan. In this drop off scenario, you would have grabbed the thing that we loaded in the beginning.
Okay.
Yep. Yep.
That's cool. What's your name, Jason?
Jason, yeah. Nice to meet you. Nice to meet you.
It was a little around 4 o'clock, and we needed to make our way to the Venetian for the AMD keynote, which started at 6:30 p.m. roughly.